Hey,
Welcome.
thank you. Hey, so I'm JB. I'm the developer lead for the tools for Unity, and I'm here with John.
Yeah, so I'm a program manager. I'm on the Visual Studio team for Visual Studio and Visual Studio for Mac, and working on the Visual Studio tools for Unity.
And John is visiting us from Pennsylvania.
Pennsylvania, yep. I'm in town for the week for this. Hang out with you.
Thank you for visiting us. How do you like the campus?
I like it a lot.
Yeah,
it's
it's
fun.
really
Good
nice
food.
here. Yes.
Lots of fun things to do, nice people to meet. So it's good. I've had a good time.
Thank you very much. So, yeah, I'm the developer lead for the tools for Unity, where we're bridging Unity, the game engine, and our developer tools. And today we'll be talking about exactly this, making game with .NET, using Visual Studio, Unity, and John, you're going to talk a little bit about PlayFab afterwards.
Yeah, so we'll talk about PlayFab. Exactly.
All right. So let's start. Let's start with Unity because this is .NET Conf. Not everybody is familiar with what Unity is. So if we're going to the slide, Unity claims that Unity is the most widely used real-time 3D development platform. What does it mean is that Unity is a tool that you can use to build all kind of experiences, 2D, 3D games, and you can use Unity to build games for more than 25 platforms, from mobiles, iOS, Android, console, Xbox, PlayStation, to AR, VR experiences, including HoloLens, and even to the web now.
Okay, so we can target pretty much everything under the sun.
Pretty much. And the reason why we're here at .NET Conf is that the real nice thing about Unity is that you get to reuse your .NET and C# skills and the Visual Studio ecosystem of tools to build your game.
Okay, so I'm a .NET developer. I'm on .NET Conf, and maybe I want to make some games, so I can reuse my existing knowledge on how to use C# and .NET, and also work with Visual Studio, something I'm familiar with.
Exactly. So you'll need to get Unity to learn about Unity, but you get to reuse all the skills that you built to learn .NET and C# to build those games.
Okay, awesome. All right, so if I'm a .NET developer and I want to get started, what's the best way to get started?
It's actually very easy. The best way to get started is to head to unity3.com and download and install Unity. It comes as an installer for Windows, for Mac, and it's going to set up everything that you need, from Unity itself to Visual Studio that will be configured on Windows and on Visual Studio for Mac with everything that you need to build, write, and debug your Unity games using Visual Studio. And if you're a complete beginner when it comes to games, like I am myself, the best thing to do is to head over unity3.com/learn. It's the learning section of the Unity website. They have tutorials from how to get started with a very simple scene with just like a sphere or a cube to FPS games or multiplayer games. They have tutorials for pretty much everything, and it's free.
Okay, so I can download Unity. I can get started with a bunch of free content. Maybe you can show me,
Yeah, exactly.
See
So
what that looks like.
let's get started with Unity. So this is. All right. So this is a program which is named Unity Hub that you can also install to manage your different Unity installations if you're using multiple of them. So we're going to go ahead and create a new Unity project. And it's basically as easy as that. Unity will create an entire project with everything that you need for your game.
Okay. So we create our project from Unity.
That's
not from
correct.
Visual Studio.
That's correct. Unity has its own concept of what a project is, and only Unity knows what it needs in a project. So you don't start using Visual Studio by doing like a new Unity project. You launch Unity, you create a new project, And from there, you'll be able to generate a Visual Studio project to modify your code of your game.
Okay. I see some chat. Can't hear me. Is that any better now? Let me know in the chat. All right, so we're waiting for Unity to run this. Looks like it's going to create our project here.
It's about to finish. What Unity is actually doing is creating this entire project structure where you'll be able to store your assets, like your 3D models, your sound, even the code of your game. And Unity here is also getting a set of pre-built resources called packages that are shipped with Unity so that you can use them directly without having to download anything else.
Okay.
So it takes a little bit of time, and that's what you get. Obviously, it's very different from Visual Studio. It's almost its own entire IDE, and that's where Unity developers are spending the most of their time. So you have your scene view, which is basically where you create the visuals of your game, or at least like assemble them. You're not really going to create models from there. The philosophy of Unity is that Unity aggregates different kind of assets. So you can use something like Blender to create a 3D model or 3D Studio, and then you're going to import it inside Unity, and it's the same for any kind of asset, like a texture that you would work with in Photoshop, for instance, and you add that to Unity, and that's inside Unity that you put everything together. Okay. So on the left, you have the hierarchy of your game, in which we have a directional light that illuminates the scene. You have the main camera, and you can go to the game view to see what the camera views. And we can add like a 3D object. Let's add a sphere in the game. And you have the inspector on your right, which gives you all the properties that you can apply to your objects. And you have your game view, and if you play, well, it's a very simple game, but it's a start. Like you have like a 3D sphere in your game. And the real nice thing about Unity is that you can change pretty much everything on the fly. You can move things around, and you immediately see what's happening inside your game from the game view. And it's a very iterative process of creating a game where you move things around, you see what works. You can even change the code of your game on the fly, and Unity will pick it up. And it makes for a very simple development experience compared to the traditional way of building game with the main loop, and you recompile your entire game before trying it. Unity makes it really easy to tweak things and see them live without having to go through the entire pipeline of recompiling everything.
Okay, all right, so we can do everything kind of live and iterative. Earlier we talked about Visual Studio, so where does Visual Studio come into play and this whole .NET and C# thing? Maybe we can talk about that a little bit.
All right. How do you put it back? So let's go back to the slide 1 second.
Yeah.
So yeah, in Visual Studio, do we have the slides? Yes.
Yep, there.
All right. So as I was saying, Unity, when you install it, is going to set up Visual Studio for you. And one of the things that Unity is going to install is something called the Visual Studio tools for Unity, just like we have tools for Xamarin, or we have tools for Azure or other scenarios. We have a dedicated plugin and workload for Unity. And in Visual Studio on Windows and Visual Studio for Mac, we call it VSTU sometimes, and you'll find me use VSTU.
Okay, so how do I get this? If I'm a developer in Visual Studio, how do I get VSTU?
So if you're a developer in Visual Studio and you've installed Visual Studio yourself, like the best way is to launch the Visual Studio installer, which has this concept of workloads now, where you can install everything that you need for different scenarios. And we have the game development with Unity workload, a workload dedicated to Unity development. That will install everything that you need to write and debug your Unity game for Visual Studio, including the tools for Unity. And on Windows, it's directly included in the box when you download Unity. When you download Visual Studio, it has the tools for Unity built in, so that when you select Visual Studio for Mac or as the C# editor in Unity, everything will be picked up and just work.
Okay. So it's already included in Visual Studio for Mac, and if I want
It's
to
already
install,
included in Visual Studio for Mac.
it's just a checkbox in the Visual Studio installer to include Unity.
On Windows, yes.
On Windows,
You just check the game development with Unity workload. But if you went through what we said, if you got like Unity first and that it installed Visual Studio for you as well, everything is ready to go.
Okay, awesome. All right, so maybe you can tell me about what are some of the features that we include in
Sure.
Visual Studio.
So what we're trying to achieve with the Visual Studio tools for Unity is to make sure that you can reuse all the skills and knowledge that you built of Visual Studio to write and debug your game. And we're trying to make the experience as smooth as possible so that you have no interruption. So I think it's probably easier if we just
Take a look.
take a look at,
Okay, let's
at
take a
what
look.
it does, and then we can go through the specific features that the tool for Unity provide for Unity game developers.
Great, yeah, let's take a look.
All right.
All right, while you're switching that, I see a question in the chat. How can Unity work on the web, and what are the requirements?
All right. So Unity does work on the web, and it's just another target that you can pick. So let me just show you this window. When you're so we've seen Unity, that's where you build your game. You create it. As we said, it's very iterative. And when you're happy enough with the game, you export it for target platform. Say you want to export it to UWP. It's going to create a Visual Studio solution for UWP. And you target iOS, it's going to create an Xcode project. And if you target the web, it's going through a pretty complex compilation pipeline and transformation process where ultimately it ends up being where the entire Unity engine and like the code of your game ends up being converted to WebAssembly that runs in the browser.
Okay.
It ends up like, so they're not really, it's a kind of like small Unity games, like they end up being, you still have to download like a game engine and assets. So that's not really used to build very lightweight games yet. Unity is working on that, but right now if you target the web, it's going to go through that process and produce like a WebAssembly game.
Okay, awesome.
All right.
So we're taking a look at how Visual Studio encoding, so let's take a look.
Yeah, so this is Unity with a project which is just a little bit more elaborate than the one we've seen before. It looks more complicated because there are trees, there's an object in the middle, but realistically it's not really that much more complicated. The only thing that I've done is I've been to something called the Asset Store, and the Asset Store inside Unity is it's this window, and you can think of it.
Let me go. I don't think we're sharing our screen here. Let me go back to
We're
this.
not.
No, let's go back. And we'll share. There you go.
All right,
That's
thank
it.
you.
Sorry about
that. So the Asset Store, you can think of it like as an app store on your phone, but instead of getting apps, you can get any kind of assets that you need to build a game. So if you're like me, have no talent to build 3D models or paint textures or create sounds, you can get started to create the games that you have in your mind using assets that you get either for free or that you buy on the Asset Store. And it's very convenient to prototype something very easily and make sure that it looks nice before investing strongly in the art of your game. And you can use it to validate like the ideas that you have of your game using assets.
Okay, so maybe I want to get like some placeholder content or something, or maybe just I don't have the time to build a model, or maybe even the skill. So go to the Asset Store and pick up
You
something.
can use it for that, but I don't want to diminish what you can get on the Asset Store. You can get very nice quality assets also. It's not only like place orders. That's the way I use it myself, like when I want to do something like this. But you get real pro assets that would not look bad in a AAA game.
Oh, so even if I want to add it in my finished product, I could go the whole way that way.
Yes.
Okay, awesome.
Yeah, it's pretty cool. So I've downloaded 2 assets, one which is called Nature Starter Kit, that provides you with trees and grass and that kind of visual. And I've opened their simple scene, and that's what you get. And I've downloaded a 3D model for Flying Saucer Uh, and I just drag and dropped it in Unity. Unity imported it. I applied the texture on the saucer, and it was ready to go. So this is my scene. If I switch to the game view, that's what I get.
Oh yeah, that's looking good.
It's actually looking great. And the way it does that is by adding special effects on the camera, like vigneting or like blurring and having like a field of view. And all those effects are built into Unity. Like you can use it for free. And you go from something that looks a little bit plain, and by simply using like scripts that are provided by Unity, you can drastically improve the visuals of your game. So again, this is a sample scene that I opened and downloaded from the asset store, a simple 3D model, and I already have something that already looks really nice.
Okay.
And so if you play the game, so it's not really a game, it's more like a scene. Then I have my flying saucer, which rotates and hovers over the ground.
Nice. So how did you make that type of interaction with that object? What exactly is involved with that?
So, scripting. Anytime you're going to want to program something in your game, you're going to use scripting, and ultimately that means writing C# code for Unity. So this is the hierarchy of my game, and I have my saucer object. And on the inspector for this object, we can see its position in the world, its rotation, but we can also see that I added like a saucer rotation script. So if I double click on it, it takes me directly to Visual Studio with the script opened. And it means that this script is attached to this 3D object in the world. So this is C#. We can recognize a few things as C# developers and a few things that are different and particular to the way Unity does things. The first thing is on the right. This is the Unity Project Explorer. And as I was saying earlier, Unity has a different concept of what a project is compared to traditional Visual Studio project. Visual Studio projects are built around solution and project files. Unity are built around folders. You have one main folder where you have all your assets. Different teams could contribute different assets in different folders and arrange them this way. And basically you'll be browsing it like folder base. And that, like the default way with the Solution Explorer is to view the different projects that Unity generates to represent what Unity is going to do when it compiles your game internally. But we're providing this tool window to make sure that it's as easy to navigate into your game structure in Visual Studio as it is in Unity.
Okay.
Because it's going to mirror exactly what we're seeing in the project view of Unity for your scripts.
So Unity is doing something a little maybe not standard that we're used to of seeing from as like a .NET developer. So the Solution Explorer has some other things in there, maybe organized a little differently, and the project files used a little bit differently.
Yes.
So the Unity Project Explorer maps things to be similar to what you see in the Unity editor, so it's a little easier to go back and forth.
That's correct.
Okay.
Yes. And we have your the C# view of your code. We have a bunch of fields which are public, which is unusual. We're going back to that. We have a type that extends a mono-behavior type, which is a special type with special meaning with the Unity engine. And we have two methods, start and update. And you can see that they're colored differently. The reason is that the reason why we're coloring them differently, and that's something that is provided by VSTU, is that those methods have special meaning for the Unity engine. When you attach a script to a 3D object or to an object, the Unity engine will look at the script and look at those different methods, and they're going to invoke it from the Unity engine with a special meaning. For instance, start is called when your game is starting. And for instance, update is going to be invoked by the Unity engine at every frame. So this code will run once when the game starts, and this will run at every frame of your game.
Okay, that makes sense.
All right.
So maybe we can look at, if something goes wrong and maybe I need to debug. I mean, I'm used to debugging my project. So what exactly can I do with Unity games?
It's very easy. So your game is running. You see that there's something wrong in, the rotation. It's as easy as putting a breakpoint and attaching the debugger to Unity. And it's as simple as that.
Oh, look, okay, there we go.
you're not starting the project like you would say for Xamarin application or a WinForms application where you start the application and you debug it. The Unity workflow is you work, again, in a very iterative fashion from inside the Unity editor. You attach the debugger, you see what's wrong, you fix it, you tweak it, and Unity will automatically see what's changed and is going to reload it. And you'll be able to replay your game in the editor with your fixes. And it's as simple as that. And so in terms of debugging, you have pretty much everything that you expect from the normal .NET debugging experience. You can step, you can view your variables, everything that you need to debug your game. You have your code stack.
Okay, I mean, everything's there.
Everything's there.
Yeah, it looks great.
All right, so let's remove this breakpoint because we're going to hit it at every frame, and
Sure.
let's keep the game running. So let's stop debugging. So let's go back to that. So as I was saying, we have those are special methods which are only identified by name, so it's making it sometimes difficult to remember them. So the tools for Unity are providing two things to make it easier. The first one is the monobehavior wizard. It's especially practical for beginners which are learning Unity and don't know all the different methods that they need to declare in their monobehaviors to get started. And we let them just create them just at the click of a button. And so say you want to handle the collision of the saucer at some point. You just use the wizard and you declare on collision enter. And that's where you get started.
So this is kind of an example of maybe a productivity feature.
Yes.
Maybe I don't remember what the method names are. Be able to generate them and get some documentation there.
Exactly, and it's going to give you a brief extract of when the Unity engine is going to call them. Say you want to learn more about the collision API. One thing that you can do is simply go to help, to the Unity API reference, and it's going to open the Unity documentation directly for the types that you've selected.
Oh, okay. Yeah, I mean, I'm always finding myself kind of searching for the API and learn how I can use it. So I can do this right inside the editor.
Exactly. And
right.
Another thing that we're doing, as we mentioned, Unity has its own concept of what a project is, which means that every time you're going to add a new script, Unity is going to recreate those project files that represent what Unity is doing to Visual Studio so that you get like code completion. One thing that we've done recently is make VSTU smart about it. So it's going to monitor the project files and only reload what's necessary so that you're not prompted all the time. So anytime you add a new script to Unity, previously you were prompted, do you want to reload the solution? Do you want to reload the project? Do you want to discard the changes? VSTU is now smart about it, and it is going to reload exactly what you need so that your Visual Studio experience always represents what Unity is doing internally.
Okay, so I can transfer back and forth, kind of that workflow you're talking about where I need to go back and forth between Unity and Visual Studio and be able to do that seamlessly.
Exactly.
That makes sense. Okay.
All right. So yeah, that's what the tools for Unity are providing. One last thing I wanted to show is about the scripts. As I was saying earlier, all right, let's go back to Visual Studio. We have those public fields, which are unusual for C# developers, but they are actually a way for Unity developers to modify the behavior of some script. So they're effectively default values, and Unity is going to look at the script, look at the public field, and represent them in the UI. So it gives you a way to very quickly tweak some parameters of your game. So say I want to change like the speed of the rotation, I want to make it like slower. I just tweak it there and see what it means. And see what it does to the game.
So I can do kind of tweak my game at runtime and
exactly, and it makes it very easy to, I don't know, like play around with like the health of an enemy that you're battling in your game, or change like the power of a gun or whatever you're building.
Yeah.
You just expose a few parameters and you can tweak them very easily in your game.
Okay, great. Well, while we're talking about that, I see a question in the chat about it's confusing. Typically, won't these monobehavior overrides be protected virtuals? So I think we're talking about those start and update methods. Maybe in the .NET world, you're used to being able to override something.
Yes. So that's I think we can say it's a quirk, which is specific to Unity. If they're not declaring those methods as virtual. One reason is that game developers have this fear of virtual methods because they've been told that virtual methods are slow. So they're just looking for it by name and directly invoking them as a standard method call, which also means that you can choose the IDE to override the method, or at least find which method you need to override, which is why we have the mono behavior wizard where you can select them. And something that we built like to go around the fact that it's not an override method is that if you're inside a mono behavior, we've added from the IntelliSense the list of mono behaviors that you can declare, like the list of messages that you can respond to in your mono behavior. So say you implemented on collision enter, you want to have another on collision exit. It's directly accessible from the IntelliSense. You press enter, and we're going to add it.
So we don't really lose any functionality there. The fact that they've
it's just something that you have to learn.
Right.
But the tools for Unity are going to provide you with ways to work around the fact that they're not declared as virtual methods.
Right. Okay, that makes sense.
All right.
All right. Let's see what. So what are we going to look at next? Maybe go back to the slides here and take.
All right. So one thing that I wanted to talk about was Unity and Visual Studio. Oh, this one.
Yep.
So, are we full screen?
Yep. We're good.
All right. Unity ships pretty much every week, and they have like 3 to 4 major releases a year. So we're not going to go into the detail of everything that's changing in Unity and all the efforts they're doing to go like from AAA like quality of graphics to like 2D pixel perfect games. What I wanted to talk about is what's new in Unity for .NET developers, because this is .NET Conf. And one thing that has been brewing for the last year, like if you've been doing like Unity development, you will have noticed that from inside Unity, the default right now is that you're targeting .NET 3.5 using C#4. And this is .NET Conf. We are already starting to discuss about C#8 in the future. Everything that's new in .NET 4.7, everything that's new in .NET Stellar 2. And Unity for a long time has been using this version of Mono as a .NET runtime that offers a .NET 3.5 API and C#4. So realistically, Unity developers haven't been able to use like all the niceties and everything that shipped since basically all those versions in .NET 4 and .NET 4.5.
Right.
And
so
years of
fixes.
Years of new features. And when it comes to Mono, the open source .NET implementation that Unity uses to run the script, well, they've now introduced in Unity 2018 an option to use this new Mono version that offers a .NET 4.7 API profile, that offers a .NET Stellar 2 profile if you want to target a smaller API profile to make smaller games. But it also comes with years of bug fixes and performances that the Mono team has been doing. For instance, for Xamarin, one big feature that and performance improvement that come with the Mono update is debugger improvement, where basically attaching the debugger to this Mono runtime would be much faster.
So are we getting those benefits with the Unity projects as well?
And no, Unity is bringing this new Mono version to run the script for the Unity games, and you're getting all of that by simply choosing from Unity to pick this new .NET version.
Okay, so we can use .NET 4.7, .NET Standard 2.0.
Exactly, and in Unity 18.3, which is currently in beta, and which is scheduled to ship at the end of the year, they included Roslyn as the default C# compiler, and they're targeting C#7.
Okay.
Which means that all the nice features, including like ref locals that are tailored for performance-sensitive code, you'll be able to use them from your Unity game.
Awesome. All right, so we can use all the nice things that we would want to use.
Exactly. So
Cool.
yeah, we're very much looking forward to that. And the VSTU team has been working in cooperation with Unity to make sure that everything that they end up supporting in terms of runtime features or API profiles, basically it just works from Visual Studio.
Awesome.
Yeah.
That sounds good. All right, so
All
that's
right. So
kind of
this
a
is
look.
Unity. This is Visual Studio, and we wanted to talk about connected games. And
Yeah.
John, that's your part.
Yeah. Let me check the chat here. Someone asked a question about how do you call a private method? So again, with those start and update, those were marked private. So
Yeah,
you
so
wanna
you're
address
not
that.
calling it yourself. It's something that you can think of it as reflection in a way. And the Unity engine is going to look at those private methods and invoke it using like the mono embedding APIs to make sure that the calls are actually fast. Not using like the system reflection API, which can be slow sometimes. So directly calling them through the mono runtime embedding APIs. That's not something that you will call yourself. As I was saying, start will be, for instance, will be called by the Unity game engine itself at the beginning of your game. So when you press play or when you exported it and and the game actually starts. And update is going to be called at every frame of your game.
Okay, so these messages are part of the like Unity API for these scripts.
Yes.
And they're ways for you to
It's-
hook into
yeah.
kind of like
It's
almost
not
like
even
events.
an API, right? It's like a protocol almost
Right,
that
okay.
you need to follow for Unity to talk to your scripts.
Okay. All right. Well, I hope that answers the question. Is it possible to integrate a Unity's scene in a WPF app?
Not today, it's not. When you create a Unity game, it comes with the entire Unity engine, and Unity like act as a container for the script and not the other way around. So it has to initialize. So Unity itself initializes the entire engine, and then draws like this your scene, and then calls into your game script. But it's not something that you can host yourself.
Okay. All right. All right. So let me talk about connected games. So we talked a little bit about like what getting started looks like. What I was hoping to talk about a little bit, once you maybe get past that hurdle and you've already started your game, and we kind of develop games, today where everything is connected. Maybe you want to do something multiplayer. Maybe you want to sync some data between devices, or you want to dynamically configure your game or something like that. So I want to talk about a little bit how you can
That's
do
true.
that.
Like even if you're installing a single-player game, today it will require you to be online.
Yeah, I mean, what if you change devices?
Yep.
Or as a developer, maybe you want to send out an update without requiring, a full download of the game, maybe some configuration change, or you're doing
That
some
makes
testing.
sense.
So I wanted to talk a little bit about PlayFab and exactly
So what's
what it is.
PlayFab?
So PlayFab is like a back-end platform for live games.
Okay.
And so that basically what it allows you to do is do a lot of back-end services and makes everything really easy when you're building games. So let's take a look a little bit about what we have for that. So some of the services that we have are player management. So things like identity and authentication. Some of those things are really hard to do. Maybe
So like if you have a mobile game and you want to make sure that your users are logging in through Facebook, that's what you would use?
Right, yeah. So there's all the social auth providers. There's a abstracted API to make sure that's all pretty easy to do.
Okay.
So you can do that across multiple platforms. There's some integrations with multiplayer. There's some commerce. You can set up like in-game stores and items, handle in-app purchases and set currencies and things like that.
Like in-app purchases? Yeah, that's... Yeah, and same as for logging in and authentication, that will be abstracted for like Android in-app purchases or iOS in-app purchases.
Right, yeah, so the PlayFab SDK will facilitate all that for you.
Nice.
So you have a way to do that. And then maybe you want to add a leaderboard to your game.
Of course.
Something simple, maybe you're getting started, you just want to have a leaderboard. So there's a simple
Just so you can
APIs
compete
here.
with everybody.
Right, yeah, you want to compete with everybody. There's also real-time analytics, so you can get data kind of real-time coming in, so you can create events, anything you want to do. The player logs in, or maybe they level up, or any type of data you might want to see in your game. You can see that information real-time, and there's dashboards to view that. There's ways to run reports on that.
So you're launching your game, and day one you can see everybody who starts playing and like, how they are progressing inside the game.
Exactly.
That's pretty sweet.
Right, so you could do all that real time too, which is really nice. So you can quickly respond to things, how they're changing in your community. And then there's some things that are called some live op features, like you can send out email messaging to your community. You could provide content updates. So if maybe you want to provide new experiences in your game and not require someone to fully update the game. So you want like some downloadable content packs or something, like a DLC.
Oh, nice.
Something like that.
Without having the users like to update the game itself.
Sure. You could also use that maybe to deliver content dynamically. Like, so your client of your game could be lightweight, and you could download like more assets. Like,
okay.
Sometimes you start up a game and there's a little bit of a loading in the beginning to download all the assets, but the actual download of the game was small, like for mobile. There's a whole bunch of systems to include that.
Nice.
And then, in-game events or promotions you want to run within your game, there's ways to manage all that within PlayFab. So it makes all these kinds of ways to manage a community in your game and make money and handle all that. It has all these different suite of products to handle all that. So
yeah, that's like your backend for your connected game.
Exactly.
Right.
So one of the scenarios maybe I wanted to show off this a little bit is you're working in a game and you want to dynamically configure it.
Okay.
So you have some configuration data, like, I have a player and I have some health or something, and I want to set that up on my server. So if I ever need to change that, I can do that, on the back end, and then my game client can sync that information.
And download it without having, like, for you to push an update of your game.
Exactly, yeah, and maybe even you're in development, and you want to do it for your beta testers and be able to do all that stuff, and respond real time and be able to change these types of things. So one way to do that with PlayFab is a concept called title data. So title being kind of like a term for your game, and then it's basically just key value storage. So you can easily set up key value storage. It's designed for configuration data that doesn't change like rapidly, but something that you could tweak or change, as you're developing.
Push to your user base.
Yeah, and push to user base, exactly. So let me show you what that looks like. So let me jump in here to our other scene.
All right.
So this is basically the same thing that we had
before.
Yeah, so I have my saucer, and let's take a look.
Beautiful
here.
saucer.
Yeah, let me run this. Make some more room here.
All right. Let's switch. Let's switch to the game view.
Yes, let me make some more room so we can see our scene.
That's beautiful.
So same thing we had before. So let me just give you a quick tour of what I changed. So one thing I did is I installed the PlayFab editor extensions. So it's an open source package you can download that.
How do you get that?
It's on the website, and you just go to like PlayFab and Unity, and then it'll take you to the GitHub page and give you the Unity package.
And
you just click on that, import it.
You import it in your project, and you're ready to go.
Yeah, so it's like an asset, same thing we talked about using from the asset store. And it gives you this little window right here. And then the SDK tab, if you don't already have it installed, you can just click Install SDK. And it will install the PlayFab SDK for you and make sure that everything is up to date.
So they even have a bootstrapper so that you can update the SDK.
Exactly.
That's pretty sweet.
So you can kind of manage it within the Unity editor, which makes it nice. So here is the title data I was talking about. You can see I have a couple key value storage things here. So I have amplitude, degrees per second, and frequency. And if we go back, let me open up the C# project here.
Right. So degrees per second maps to the degrees per second of rotation of the saucer, and amplitude of frequency is of the over movement that we had previously.
Yeah. So these were the variables that you had made public, and you were showing in the inspector, and we were tweaking them in the inspector. But that's local to the development machine that we're doing. So now what we're going to do is we're going to push those variables to PlayFab as title data, and then I'll be able to change them on the back end, and then our game client will sync with that.
So that if players were playing this game live, you could push new changes and new configuration to them.
Yeah, I mean, maybe this isn't a terribly interesting scenario, but you could think if you were running, player health or something, and maybe their spawn health was too high. You learned from analyzing some of your events,
and your player never died.
Right, so you could go back in and tweak that on the back end, and then the next time the game client launches, you could be syncing that data. So you could tweak those type of values. So you can take a look here.
All right.
So here's what we have. So we call the PlayFab client API. It has method built in for get client title data, and then we just parse the result to get our key value storage. So it returns a result with key value.
So very easy, yes.
Yeah, so very simple. And
one API call, like using the keys that you set in the configuration, like automatically PlayFab will like get the right ones for you.
Right, exactly.
Very nice.
And this key value storage is just 2 strings, so you can make them whatever you want. So when maybe your game scales, you could make the values like full JSON values.
Yep.
And I'll show you what that looks like in a minute. So you could really make this sophisticated as you scale.
All right.
So right now I set these, the default values are what's running. So if we go here and we just hit update, which is going to call that API, you can see now
all right, it's slowing everything
slowed
down.
everything down. I changed the values, and that's because the amplitude I set to 2. And what these values are here is if we go back into
it makes for
PlayFab.
less.
So here's the PlayFab portal, and here's the title data. So here's what I did on the back end. So here's the 2, and I changed the degrees per second. You can do it here in the PlayFab website on the back end too, or for some of these things you can do right here in the
like
editor
from the
extensions.
Unity extension directly.
Right, and that will sync it to the back end for you. So it allows you to not have to leave the editor when you're doing stuff like this, which is kind of nice if you're the developer working on this. You can also view it as well, which is really cool.
It makes for a less menacing saucer.
Right, so that's kind of a basic look of how you might use something like title data in PlayFab to dynamically configure or deliver configuration to you.
And it shows the entire point of PlayFab that it's very easy to call something like their API, which is going to abstract a lot of things from you, from authentication to or the communication to your backend and the JSON parsing.
Right, exactly. So something that I can show some more of that, but if you want to learn more about PlayFab, you can go to playfab.com/features, and you can take a look at that, and you'll see everything that's available there.
Nice.
So
do we have time for?
Yeah, I think we have
one more
a few
demo?
minutes here.
All
I'll
right.
show you one more demo of something that's cool. So we have this sample here. That's a Unity game. It's called Unicorn Battle, and I'll just show a little bit maybe more of a full story of how PlayFab and can be used for like an actual game project.
Okay.
So let's launch this, and we'll do it windowed. You can see it's made with Unity.
Yep.
Powered by PlayFab.
Beautiful.
All right, so we'll go in here. So you can set up all the authentication too, but I'm going to skip that for the demo here. So here's what we have. So this is like my character selection screen. And you can see here, I already made a character, but more interestingly, let's look at like a new character. And you have some different unicorn types here that you can select. And you can see these abilities and like starting stats that I might want to have in my game. On the back end,
yeah, I was going to say, I bet that's something you can configure.
Yeah, so if you look here at like this classes record here, if we look at the JSON for that, you can see.
Like, yeah, you can even have complex JSON objects in there.
So here's an example of like me uploading a full JSON file. Maybe it's a little small, but you can see there's like, here's Bob, here's Nightmare. Yeah, maybe that helps to see that. So you can see like I could change any of these values for the game that I want. So there's all like the starting values for the game. So that's pretty cool. Let me take a look here.
That's really nice.
If we create, well, I'll just go to my existing character here and click on play. So here's my character. Once you create your character, you can go back here and you can see, okay, here's my character that I created named Roach. You can see everything that my character has. Let me go into character classes here. Oh, right. So I think in my inventory, I got rid of it. Let me go back to.
That's a complete game.
Yeah, it's actually a lot of fun. Well, it's not here anymore, but take a look at this. So this is like an inventory, so you can handle inventory. You can create items. So here's alfalfa juice, and there's a bunch of items in here. So like crystal container was the one I was going to show you. That's like a chest. Let's see if.
So, do you have public samples of PlayFab that people can run?
Yeah, there are some samples you can find on there. I'm
On
not
the
sure. I don't think the Unicorn Battle is a public sample. I'll have to double check on that. But yeah, there's lots of learning material. There's a lot of tutorials, especially for Unity. PlayFab
on their
also.
GitHub.
Yeah. It also supports multiple platforms. So if you're not building with Unity and maybe you want to work on some other engine, you can also do that too. There's SDKs for multiple game platforms and also different languages.
Nice.
So yeah, that's pretty much it.
All right.
So let's see if we have any questions for anybody. If there's anything in there. No, it doesn't look like it. All right.
As someone who started gaming with text-based mods, being able to create my own video games at some with graphics still messes with my head. Yeah, I know. Like when I look at Unity, I mean, if I had Unity when I was like 15, I would have even been a bigger nerd. I would have never left home, I think, and I would have spent countless hours just building worlds with Unity. It makes it so easy.
Yeah, I agree. That's kind of why I got into it too, because it makes it easy.
Yeah.
You could take, my background being with .NET and Visual Studio. I wanted to, of course, reuse that knowledge, and then being able to do it with Unity made it really easy for me to transition into kind of tinkering with games. I saw someone mention in the chat they wanted to do it as like a hobby. It's perfect.
Yeah.
Try it out. It's free. PlayFab is free. You can get started with that in Visual Studio.
Like you can use Visual Studio Community as well.
So I mean, there's really, there's low risk. Do it, try it out. You send us questions. JB and I are both on Twitter.
And I think, that's the best conclusion you can get. It's easy to reuse your C# and .NET skills as .NET developers to build very high quality game using Unity and PlayFab on the back end.
Exactly.
All right. Thank you very much, everybody. Have a good weekend.
Thank you.
Hey everybody, we're live from Studio C in Channel 9 Studios.
And we're done!
We're done! Yes! No more.
Thank you so much, everybody, for watching. It was such a successful event. The 3 days have been absolutely fantastic. This last 24 hours have been like crazy, right?
Crazy.
Yeah.
Overnight, 2 in the morning. Thanks to James and Emma for joining us in the middle of the night. Oh my gosh.
Yeah, absolutely. So, Javier, little statistics on the Community Day stuff, huh?
Yeah, well, not even that. I was just showing us like this, the entire 24 hours were cleverly managed using a printed out spreadsheet and red dots. So this is the core behind .NET Conf. But what I think I was going to show you was this.
The history.
A
little bit of a history lesson here.
We started long ago in 2012 with ASP Conf many years ago.
So these are signs that we all sign each year to say, look who participated.
So there was like 5 people back then.
That's right, because the internet didn't exist back then.
Internet hardly existed.
That's right. I couldn't find the 2013 one, so we're going to skip straight to
13's an unlucky number.
We're going to skip to first .NET Conf 2014 out of Channel 9.
Out of Channel 9 Studios here. That's like
Very cool.
really
The
good
old
stuff. That
studio.
was the actual .NET branded.
That's
Conf,
right.
All right. So we
2015
expanded.
I'm running
2015.
2015 right here.
I'm running out of space here, Beth.
It's getting a little more full.
I wasn't in marketing yet, so as you notice, not a lot of people there.
I'm running out of space, Beth.
This was my first .NET Conf.
2016.
Okay.
2016. Very nice.
Can I still?
There you go, Jeff.
What's going on?
Okay.
2017.
2017. Last year was 2 streams. Remember that craziness? Lots of people.
Multiple channels. You pick whichever.
We were in Stockholm. We were in
Man,
Sweden.
That one was terribly crazy.
Choose your own adventure.
Can I have that one too? Okay.
There we go.
Okay, Brian.
And last but not least, the member of the
This
family,
year.
2018.
All right, on air, 2018.
Okay.
Tons of awesome people. What'd you guys think? It was awesome.
You guys
huh?
should we do this again?
Jeff, here we go.
Hang on, let me grab that one. I got that one. I got it.
All right, yeah, guys. Thanks
See
for
you
watching.
so much.
See
See
you
you next year.
Bye.